In our previous video, we found out we can solve an exponential equation if we have a common base. But sometimes we have to do a little bit of work to get that common base. And the idea is we're going to get a common base by factoring the bases. And what I mean by that is if we see a number like 81, we could rewrite that number 81 as 9 squared. Maybe that would be a common base. Another way we can write 81 actually is 3 to the 4th power. So sometimes there's some options as we work for that common base. And then what's going to allow this all to work is that exponent property from an earlier section where we had the power of a power. Remember, when we had the power of a power, we would multiply those together to get a to the m times n. And sometimes with these, it might look a little bit more involved, but it's the same principle. If I've got a to the m to the, maybe it's a sum, p plus q, we can still do that by multiplying the powers together. We're just going to distribute that m onto both parts. So we would have a to the mp plus mq. And those properties are going to allow us to solve exponential problems that don't have a same base by getting the same base. For example, if we had 27 to the 2x equals 9, those are not the same base. But we can get the same base by factoring 27. 27 is divisible by 3 times. It's actually 3 to the 3rd power. And if you're not sure, you can always factor the 27 by dividing out the 3, leaves behind a 9, divide out a 3, leaves behind another 3. And so we end up with 3 to the 3rd power is 27. It still has that 2x on it. And 9 is 3 to the 2nd power. Notice when doing that, I've got that common base of 3 on both. We can then multiply exponents to get 3 to the 6x equals 3 squared. And since the bases match, the exponents must also match. 6x equals 2. And we can divide by 6 to find out x is equal to, after reducing, 1/3. Let's try another example. Let's try 8 to the 2x minus 4 equals 16 to the x plus 3. Well, if we factor the base of 8, we get 2 cubed, and that's still to the 2x minus 4. Similarly, we can write 16 with a base of 2. 16 is 2 to the 4th power to the x plus 3. Notice I could have written 16 as 4 squared, but then the bases would not have matched. The goal is to make the bases match. So make sure as we're factoring, we're shooting for those matching bases. Now we can multiply those exponents together by distributing onto both of them. So we now have on the left 2 to the 6x minus 12 equals, on the right, 2 to the 4x plus 12. And if the bases match, the exponents have to match. 6x minus 12 equals 4x plus 12. Let's move all the variables to the same side by subtracting 4x from both sides. When I do that, I get 2x minus 12 equals 12. Add 12 to both sides, and 2x equals 24. And divide both sides by 2, and x is equal to 12. So it seems sometimes we're able to factor the bases and get a common base, which allows us to set those exponents equal. This strategy also works for fractional bases, and that'll be what we look at in our next video.